Oh, it's time. We're going to graph some rational functions here. I even got a little bit of helper. What's up, Jenny? You ready to graph some rational functions? Yeah? All right, we're going to graph some rational functions. Let's do it. All right, first things first, when we're graphing, we are going to factor everything we can, all right? We're going to factor everything we can. So my numerator has a GCF of 3. So I can take out a 3, and I'm left with x minus 2. In my denominator, I got to find out what multiplies to negative 8 and adds to positive 2. Jenny, do you know what multiplies to negative 8 and adds to negative 2? She said 4 and negative 2. All right, so we got x plus 4, and we have x minus 2. Lovely. Now, at this point in time, we're going to look at our domain. Okay, so our domain, we're going to look at our denominator. What values will cause our denominator to be 0, thus causing our whole entire function to be undefined? Well, that would be negative 4 and positive 2. And there's different ways of writing this. We're going to keep it pretty simple here and have it as x cannot equal negative 4 and x cannot equal 2. If I had negative 4, then I would have 0 in the denominator. I can't divide by 0. It's undefined. All right, cool. Next, we have our wholes. Well, our wholes are going to be what cancels. So if this cancels here, then that means that I have an x value of 2, right, for that whole. But how do I find my y value? Well, let's rewrite our function now in the most simplified form that we can, 3 over x plus 4. Now that we've canceled out those x minus 2's, we're left with 3 divided by x plus 4. So if I have an x coordinate, how do I find my y coordinate? Well, I can take that 2 and I can plug it in, so 3 over, and then 2 plus 4. That's going to be 3 divided by 6, which gives me 1/2. So my y coordinate will be 1/2 for the whole. Cool? I can go ahead and plot that if I'd like to right now, or I can wait until you get everything else. I'll wait. All right? I don't want to jump ahead. All righty. Next up, vertical asymptote. Vertical asymptote is decided on what's left in the denominator. I'm going to take that, the x plus 4, and I'm going to set it equal to 0, and I'll get x equals negative 4. My vertical asymptote is the equation of that line, which is x equals negative 4. Cool. It's awesome and fantastic. All right? You got to have x equals. Got to have x equals. If you don't have it, it is incorrect. It's not just a number. It's an equation of a line. All right, next up is the horizontal asymptote. The horizontal asymptote, we have 3 rules. 3 rules for the horizontal asymptote. Quick refresher on those rules. So if we have the degree, the exponent, the degree of my numerator is small over the degree of the denominator is larger, so smaller over larger, then I'm going to have y equals 0. This is the situation that we have in this one. My degree in the original here is 1 for my numerator, and it is 2 in my denominator. Now, when I simplify, the degrees still stay where it's smaller over larger. I like to look at the original. So I have small over large. That means my horizontal asymptote is y equals 0. If they were the same over the same, then it would be the coefficient over the coefficient. We'll address that another time. All right, so for this one, y equals 0. Bingo, bango, we're good. Now, x-intercept. So how do I get my x-intercept? Well, my x-intercept, it crosses my x-axis. It crosses my x-axis when my y value is 0. So how are we going to figure out when it's doing that? Well, again, I want to know it's somewhere along the x-axis. My y value is 0. So what if I were to set my equation equal to 0 here? Okay, let's do that. I'm going to move myself out of the way for a little more room. So if I had 0 equals my entire equation, I guess my simplified one would be just fine, right? Easier to work with. Can I ever make this 0? Well, if I had negative 4 in for my denominator, I'd get 3 over 0. I can't do that, right? I can't get this thing to equal 0 because I'm always going to have 3 divided by some number, some positive number divided by a number. I can never get it to equal 0, so there's no x-intercept in this one, okay? Had there been a variable in the numerator, then I could have one. We'll see that another time. All right, y-intercept. Let's see here. Well, when is it crossing the y-axis? Well, my y-axis is this guy here. My x value is always 0 there. So how about I plug in 0 for my x's? And I can do so into my simplified equation. So I have 0 plus 4. That's going to be 3/4. So I had 0 in for my x, and I had 3/4 for my y output when I did that. All right. So I've got my asymptotes, I got my whole, I've got a y-intercept, no x-intercept, and we'll see y here in a little bit. I think it's time we can graph this. Let's do it. So my vertical asymptote, that's the green guy. Let's get a ruler out. Boom. I want that to be 90. I want that to be 90. There it is. Okay, so we've got my vertical asymptote. Lovely. And next up, we'll get our horizontal asymptote. That's the y equals 0. Come on, ruler. There. Oh, come on. There it is. All righty. Y equals 0 is my horizontal. Lovely. All right, now I can start plotting some points. So I got the whole was 2, 1/2. So we got 2, which would be right here, and 1/2. I'm going to do an open circle. That's going to give me my whole there. 2 for the x, 1/2 for the y. Then, let's see here. We had our y-intercept of 0, 3/4. So we could plot that. I'll match that up with that color as well, so we know where everything is. There we go. And that's all I have for this. Okay. So I know, based on the general shape of these graphs, and I'll use light blue here, since that was my, I don't know, I started with that, whatever. It's going to go through here. It's going to jump over that hole, and then it's going to curve up and follow along the asymptote. There we go. So that's this portion of the graph, okay? So I've got to go to the hole, I got my y-intercept, and I curve up. The asymptotes help me shape the graph there. Now, I need another portion of this graph. It's either over here in this section, sectioned off by the asymptotes, or it's down here, okay? So we can pick a point to do that. Some of you might be wondering, why is it not down here at the bottom right? Well, if you remember, in order to be a function, it needs to pass the vertical line test. And if I had some graph action down here, now the vertical line test would go through twice. It does not pass it. It's not a function. So it can't exist anywhere down here. It's got to be one of these two sections here. Well, I'm going to go to the left of my asymptote here. How about -5? What if I were to plug in -5 into my simplified function? Let's do that. So if I plugged in -5, I'd have 3 divided by -5 plus 4, and that would be 3 over -1, which is -3. So I have the coordinate of -5, comma, -3 that I can plot. -5, -3. There we are. And now I've got this wonderful, wonderful, boom. Wonderful. That's fantastic. That's good stuff. That arrow kind of missed there, you know. And Jenny, are you trying to figure out how you want to sit down? We're going to spin around. And there we go. Perfect. Wonderful. Perfect. Like this beautiful graph. I hope you guys loved it. There's always some different things with each one, so we'll do a few examples. But America, freedom, rock and roll, Costco. River Dog, Jenny on the gram. And Yoro. See ya.